So this whole entry that you're on is on radicals, but there's a lot of different aspects of radicals. So while we do have like what radicals are, that was a previous video that you watched, and how to identify the different parts, we also have a way to simplify radicals. Now, the easiest way to simplify radicals is by doing the prime factorization of the radicand. Okay, so remember, the radicand is what is inside that radical symbol. Let me first show you, okay, a technique for finding the prime factorization, and that's what I like to call the birthday cake method. Okay. Now, the birthday cake method is similar to making a factor tree, and of course, if you're more comfortable with a factor tree, which you should have learned in 6th grade, you can do that. But I use what's called the birthday cake method, so I'm going to show that to you just in case you want to try something different. So let's, for example, okay, find the prime factorization of 42. Okay, here's how I'm going to do it. I'm going to put 42 on the bottom as my first tier of a birthday cake. Okay, now I want a prime number that goes into 42. It can be any prime number, right? Now, 2 is a prime number, okay, and I notice that 42 is even. So I'm going to start with 2. And 42 divided by 2 is 21. And now I have another tier to my birthday cake. And I'm looking for another prime number. Well, 3. 3 goes into 21. And 3 goes into 21 7 times. And there's another tier. Okay. Now, what's a prime number that goes into 7? Well, 7 is a prime number. And 7 goes in 1 time. And so that 1 is like the birthday cake candle, right? So that means you're done. We're done with the making the tiers of the birthday cake. So the prime factorization of 42 is 7 times 3 times 2. It's all of those prime factors that I divided out. Okay? And this is going to be really important when we start simplifying radicals, because we're going to be taking out prime factors that are common. Okay, so let's do one more example, and then I'll have you do a couple examples on the left side. If you prefer, after the second example, if you prefer to use a factor tree to find the prime factorization, you can do that too. But I'm going to stick with the birthday cake method for this one. So in this new example, I'm asked to find the prime factorization of 120. So we've got 120, and I'm starting at the bottom here. And I'm going to leave some space because I build my cake up. It's not an upside down cake, although those are pretty good. And I'm trying to find a prime number that goes into 5. I'm sorry, that goes into 120. And the first one I'm thinking of is 5. So 5 goes into 120 24 times. Okay, so that's my next tier. Now, what's another prime number that goes into 24? So you might be thinking, well, 6 goes into 24, but 6 isn't prime. 4, but 4 is not prime. Right? But it is even, so 2 is always going to work. Okay, and 2 goes into 24 12 times. And right, 12 is another even number, so we know 2 goes in that one 6 times. And again, 2 is going to go into 6 3 times. And 3 is a prime number. It goes into itself once, and there is my candle to my birthday cake, which means that I am done with the birthday cake method. So the prime factorization of 120 is 5 times 2 times 2 times 2 times 3. And if you wanted to rewrite it in descending order, you could do that too, right? But that is the prime factorization of 120. On the left side, you're going to do these two examples, or these two on your own problems. You're going to write the prime factorization of 40, and number 2 is write the prime factorization of 64. When you're done with those two problems, by either using a factor tree or the birthday cake method, whichever you prefer, but when you're done, you're going to show your teacher, so you can move on to the next step.